Okay, so with that background, let's directly jump to Prewitt edge detector. And we already saw the steps which are required to compute edges using this algorithm, but let's quickly go through all these steps one by one. You will have your input image. The first step is you will perform smoothing in, let's say, X direction, and which is going to give you a blurred image. Okay, you know that mean we have seen this earlier as well, like smoothing of your signal actually helps you in detecting edges. Then you will compute a derivative in X direction, which will give you edges in the X direction. Similarly, you will repeat the same step for the Y-axis. And again, in this case, you will smooth along Y-axis, which will give you blurred image. You will compute derivative in Y direction. So it will give you like edges in Y direction. And you can then combine these two together to get like the derivative map. Now, if you look at like the filters which are used in this algorithm, we have all ones, which is going to smooth your image. And for derivative, you have a 1 and -1. So this mask we have seen before, this gives you edges in the X direction. All right. So one way is you can actually first perform smoothing using this filter, and then you can perform like you can operate this derivative mask on this blurred image to get the edges. The other way, which is like an optimized version, is you don't have to perform two different steps. You can actually combine these two filters as a single filter. And then what you can do is just use this filter on the input image, and that is going to give you edges. All right. So this is also, you have seen like the associative property of convolution or correlation, right? So if you are operating, if you are like using two different filters on the image, you can actually combine the filters together to actually perform filtering and then use that filter on the image. So we studied those properties in one of the lecture, and this is exactly doing the same. Now you will think about like how we can actually get this filter using these two filters. And basically it seems non-trivial, but if you just take like paper and pen, and you just take maybe one of these as image patches and the other as a filter and perform this filtering operation, you are going to get this filter. You might get like slightly different. I think the direction will be different. Instead of 1 over here, it will be all negative. And instead of all negative ones, it will be all ones. But that doesn't matter. I mean, we have talked about that. It doesn't matter whether you use forward difference or backward difference. The result is not going to change. Okay, so the idea will be what you will do. Let's say you consider this as your image patch and this as your filter, and which seems like an obvious choice because this is like a smaller dimension filter. So in that case, what will happen is first you will have to perform padding on this patch. All right, so padding we studied, I think, in one of the lecture, where you have to perform filtering and you have the edges. So how to deal with that? So in this case, let's say you put like all zeros in the border, and then that will give you like a bigger patch. And then you will be able to put this filter on each and every location in this input image patch. And after performing filtering, you will exactly get this filter. Okay. So if you can try like that is a homework. If you have any questions, any doubt, we can take those later. Similarly, you can perform the same set of steps in the Y direction. So in this case, your smoothing operator will be again all ones. So this kind of a variation of a box filter. And again, this is the derivative mask in Y direction. And you can in fact perform these two steps as a single step just using this filter.